Hi class, welcome to this new video still on tutorial 10 where we have to answer the first question. So this is how the question is labeled. Now basically you are asked to identify the curve C by reducing the equation into standard form with respect to new axis. And then you have to sketch the graph of C with respect to the new x and y axis and show the direction of the new axis. Now this exercise on is focusing on the part of quadratic forms. Now, as a solution, right, remember that two variables quadratic forms equation are defined as follow: 2axy plus cy squared plus dx plus ey equal to minus f can be written in a compact form or in a matrix form as follow, right? A b b c x y. So this is a symmetric matrix plus d e x y equals to minus f. Now, once we have this, we can therefore apply it to our equation, right? See the equation that we have here. We can then write it, right? Applying this equation. This will give me that I will have x y times 1, 2, 2, 4 times x y, right? Plus I will have a 4 square root 5, 3 square root 5, xy equals to 15. So you can see that this is a symmetric matrix. We call it matrix A. So because this was the first step, right? And because A is a symmetric, therefore A can be orthogonally diagonalized, right? So how to do that? The next step will be to find the eigen values and their corresponding eigenspace that contains the eigenvectors. So to find the eigenvalue, we need to solve the equation delta A minus lambda I equals to 0, and this is 1 minus lambda, right? 2, 2, 4 minus lambda. So if you have this, you will have that it is 1 minus lambda times 4 minus lambda minus 4, which is equals to 4 minus lambda minus 4 lambda minus, sorry, plus lambda square minus 4. So this will give me lambda times lambda minus 5. So equal to 0. We have two values of lambda. Lambda equals to 5 and lambda equals to 0. So we have two eigen values. Therefore, finding the corresponding eigenvectors for lambda equals to 0, right? What will we have? Yes. So we have to solve this equation times v equal to 0. V is a eigen vector. So, and this will give me, if I write it in the augmented matrix form, right? And if I do the reduction, I simplify the second row times 2. I will have 1, 2, 1, 2, right? And if I do R2 minus R1, this will give me 1, 2, 0, 0. Therefore, it means that my the vector will be any scalar of minus 2, 1 with alpha belongs to R, right? So if I check for lambda equal to 5, I have to solve this equation, v equal to 0. So I have to solve the equation which will be minus 4, 2, 2, minus 1 in the augmented form. So if I simplify the first row by um, by 2, right? I will have that so R1 divided by 2 will give me minus 2, 1, 2, minus 1, 0, 0. So I can simply do R2 equals to R2 minus plus, right? Plus R1. So this will give me minus 2, 1, 0, 0. Right. So from here we can easily see that the second vector or the vector here, I can put a beta value here, will be 1, 2, right? With beta belong to R. Right. So we therefore have we can have the matrix, the P, the invertible P matrix will be 1, 2, and then minus 2, 1. So we can have the Q matrix, which is the orthogonal matrix, 1 over square root 5 of 1, 2, minus 2, 1. So once we have that, and then we have the D matrix, which is the D matrix will be given by 5, 0, 0, 0, right? Now you can now define or introduce the new axis, right? By letting x equals to q capital capital X. So once we have that, we can therefore we know that X transpose equals to Q T Y T X T, sorry, which also equals to X T Q T, right? And we can replace it in the equation, right? This equation here, replacing everything in there, right? Will give us after doing some simplification that the X transpose of 5, or let's say X transpose first of dx, right? Yes, plus square root 5 of 4 3 q x equals to 15. Now, then I will have xy times 5 0 0 times xy, right? Plus square root 5 4 3 and 1 over square root 5. I'm writing now the q matrix minus 2 1 times xy equals to 15. Now I can also now here apply some simplification and all this, right? Or if you want, I can have x, y, and times 5y, right? Yeah, and then 5y 0, which also will be equal to 4 3 times x minus 2y 2x plus y equals to 15. So this gives me 5x squared plus 4x minus 8y plus 6x plus 3y equal to 15. So 5x squared plus 10x minus 5y equals to 15. Now it will give me 5x squared plus 10x, right? Do you see? Plus 10x plus 5 minus 5 minus 5y equals to 15. So I'm doing this so that I will be able to complete the square over here, right? So this will give me 5x plus 1 square, right, minus 5y equals to 20. So if I divide everything by 5, I have 1, x plus 1 square minus y equals to 4, right? So which type of curve is this? This is a parabola, right? And we can sketch this a parabola, right? Okay, so I have 1, 2, 3, 1, 2, 3, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I can see, and you can have a little table over here where you have your x and your y, and you will realize that for y equal to 0 you have minus 3. Yeah, and for y equal to 0 you can also have 1, and then you have minus 2, you have minus 3, and you have minus 1, you have minus 4. So these are just guiding points for you to plot your graph. So we have minus 3 and 1 for y equals to 0, right? And then when x equals to 0, y is minus 3, and then when x is minus 1, y is minus 4. So we can use these 3 points coming this way to plot our parabola. Okay, so this is sketch for a parabola. Now you need to find a new axis, right? Then remember that when we let x equals to qx, right? And from here we can therefore look our our new our new axis. If we do q times 1 0, right? If we do that, you have 1 over 5, 1 2, and if we do q times 0 1, you have 1 over square root 5 minus 2 1. So our new axis therefore will be, I have 1 2 1 2 somewhere here, and I have minus 2 1 minus 2 1 somewhere here. So once this is my new axis here, this is the x, and then this is the y. Okay, now we can all see that from the x here, I can have a minus one, minus two, minus three, minus four, right? And minus four. Then I have one, two, three, minus four. Then yeah, I have one, two, three, minus four. So I am here, I have zero here, I have one here, and I have minus three here. So I can easily sketch, right? Sketch this way. Yes. So this are my new axis, and this is a new sketch in yellow. Yeah. So I hope you understand and you enjoy this video. And I would advise you to do more practical exercises on quadratic forms so that you will grasp the content of this part in your lecture notes. Thank you very much.